At the very end of the last video, we looked at the example where I was drawing a card from a standard deck of 52 cards, and I asked the question, what's the probability of that card being an 8 or a king? We noticed that there were 4 8s in the deck, and there were also 4 kings in the deck. And we also observed that there was no overlap between those two events. You could never be drawing a card that was both an 8 and a king at the exact same time. As a result, we describe those two events as being mutually exclusive. So let's talk a little bit more about that term right now. So two events are mutually exclusive if it is impossible for both of those events to be occurring at the exact same time. Let's take a look at these few practice problems, and hopefully this concept will make a little bit more sense. Example A, a die is rolled. Event A is that the die comes up a 3, and event B is that the die comes up an even number. So my question to you is it possible to roll a die and get a 3 and then at the same time get an even number? Can you have overlap between these two events? Can you get both a 3 and an even number when you roll that die? And as you know that 3 is an odd number, you realize that you cannot have that happen. It's completely impossible to have event A and event B together. And as a result, we would say that these two events are mutually exclusive. They cannot happen, they both cannot happen at the same time. Example B, a fair coin is tossed twice. Event A is that at least one of the tosses is a head, and event B is that at least one of the tosses is a tail. So if you toss a coin 2 times, can you have the situation where you have at least one head and also the situation where you have at least one tail? Absolutely. If you have heads tails or tails heads, then you can have both of those events at the exact same time. And since there is a little bit of overlap between these two events, and it's not impossible for those events to be occurring at the same time, we describe them as not mutually exclusive. Okay, example C. A college student is chosen at random. Event A is that a student is 21 or older, and event B is that the student is taking a statistics class. So is it possible to have overlap between these two events? Can you have students or can you have a student that is 21 or older, and at the same time, can that student be taking a statistics class? Absolutely, you can have overlap. It is not impossible for those two events to be occurring at the same time. So once again, we would say not mutually exclusive. Okay, so what is the implication of two events being mutually exclusive when we're working with this probability of A or B formula that we were working with before? It's actually down here. Let me underline that. And so before we saw that the probability of A or B was equal to the probability of A plus the probability of B minus the probability of A and B. But two events that are mutually exclusive do not have any intersection. So in terms of that Venn diagram, you do not have any overlap. When you have mutually exclusive events, you have a picture that looks like this. One circle would look like this, and then the other circle is completely separate from it. There is absolutely no overlap. And so the probability of A and B both occurring at the same time is 0. And so if this turns to 0, then you can see that we end up getting this formula right here, which is the probability of A or B is equal to the probability of A plus the probability of B. And again, this only holds if A and B are mutually exclusive. Now my advice is to simply identify a problem as being an OR problem, as we've already seen a little bit in a couple of videos. And if you identify it as being an OR problem, you can consider reasoning through it, as I've suggested before, or you can consider using this formula. But you should know that this right here is a formula that applies whether you have mutually exclusive events or not. And so if you have mutually exclusive events, you don't have to memorize this as being a separate formula or anything, because you'll come to the realization that P of A and B is 0, and that this formula is really simplified into this right here. So This is not really making our P of A or B problems any more difficult or giving you anything else to remember. It's really just speaking to a little bit more vocabulary that we can incorporate into some of the problems that we're talking about. Okay, let's take a look at one more thing in this video, and that's the idea of a complement. And we actually use complements all the time in statistics just to kind of reframe our thinking in certain probability contexts. So let's talk about the definition and then we'll get into a couple of examples. If A is any event, the complement of event A is the event that A does not occur. And the complement of event A is denoted as A with this C in the upper right here. So the probability of the complement to event A is 1 minus the probability of event A. And that is based upon the fact that the probability of event A plus the probability of the complement to event A is equal to 1. And if you just manipulate this equation a little bit where you bring this to the other side, then you get our formula right here. And again, it's often easier to think in terms of complements in a lot of situations. For instance, assume that the probability that it rains on a given day is 30%. What is the probability that it doesn't rain on a given day? Well, the probability that it doesn't rain can be thought of as 1 minus the probability that it does rain. And so by thinking in terms of complements, we could say 1 minus 0.3 or 0.7 is the probability that it doesn't rain on a given day. And we do this all the time. You know, when you look up the weather online and you see that there is a 30% chance of rain, then maybe you're thinking to yourself, well, there's a 70% chance that it's not going to rain. Okay, how about this one right here? What is the probability that it rains at least once over a 10-day period? Now, this is actually a really tricky question because when I say what's the probability that it rains at least once, then I'm actually asking for the probability that it rains once, or exactly twice, or exactly 3 times, all the way up to 10 times. And so that can be really tricky to answer, and we probably don't want to sit here and find the probability that it rains exactly once over a 10-day period, and that it rains exactly twice, and so on, and add all of those things up. So let's use the idea of a complement here. The probability that it rains at least once can also be thought of as 1 minus the probability that it never rains. And that is because the event of it never raining over a 10-day period is the complement to it raining at least once. Because if it rains at least once, that means it rains either once or twice or 3 times all the way up to 10 times. And the only other event that you can have is that it never rains. Now, if it never rains, that means it doesn't rain the first day, and then it doesn't rain the second day, and then it doesn't rain the third day, all the way up through that 10th day. And so to solve this, what we would actually do is the following. We would say 1 minus the probability that it would never rain on a given day, but then we would have to multiply that probability by the probability that it wouldn't rain on the next day, all the way through this 10-day period. So it leads us to 1 minus 0.7 raised to the 10th power. And if you're looking at this right now and you're a little bit confused, don't worry, because this is actually a concept that we're going to cover a couple videos from now. It's one of the final topics in this module where we talk about the general multiplication rule. The important thing is not this piece of the problem. The important thing is that you're seeing that a complement is really necessary to make this a manageable problem to solve for us. So I want your big takeaway from this example to be, when you see those terms at least once in your homework, that you are going to take that problem and you're going to say that the probability of something happening at least once is equal to 1 minus the probability of that event never happening. Okay, so this is the big piece to star here and refer back to in your notes when you're looking at these types of problems later on. Okay, so we've got one more section in this module now. Keep going with this. Dig into the next video right now. Thanks.